So this is basically a rectangle, and I have made a slot onto it.
Okay.
Removed some material, and I placed 4 holes inside it. Okay.
Okay.
And the dimensions for this is, you can, if you want to see, I have given the dimensions as 200, 150. 200 is the length of the rectangle. 150 is the width. Then for the slot, I have given it as 100 and 175. Okay. The length is 175 and the width is 100.
Okay.
Then for the holes, all holes have a diameter of 20. Okay.
Okay.
So these are the dimensions. If you are able to, you can create it afterwards. Okay. Or if you want, you can create it with me and you can do it now.
Okay,
Okay.
sir. Now I will.
So if you are able to create, you can create it now and we can do it side by side. Okay.
Okay. Now I will do. I am doing now.
Are you creating it now? Or
Yes, sir.
what? I didn't hear you.
Yes, sir. I am creating now.
Okay. Fine. So first start with the rectangle. Then the extrude height for this rectangle I have given it as 50.
50 height.
And inside I have cut the material to 35. And the holes that have been cut through. Okay. So today we will be starting with the first operation called face milling. Okay.
Okay.
So we'll see how we can do certain operations using face milling. So tell me when when you have finished completing the model. Okay.
Oh, okay, sir. Model
So
completed.
you have great.
Yes, sir.
Okay, you have completed the model.
Yes, sir.
Okay, so next what we'll do is we'll come into the file tab, then select new, and select general set and click OK. Now you need to save the model also. Okay, just save the model
Okay.
before doing this. Okay.
Okay.
Now once we come into here, what are the other? My main aim is to create the desired model. Okay, into this shape, and we need to see the manufacturing process for this. Okay.
Okay.
So first, what I will do is I need to first remove the material on top, then remove the material inside the slot, and then remove the material inside these 4 holes. Okay. So that is the main thing. So we will be starting with a block of rectangle, then we will be milling it to the required form. Okay.
Okay.
So that is our aim. Are you able to hear me?
Yes, sir. I'm hearing.
Okay. Now, first, what I will do is, if you want, you can change the name of the program order.
Okay.
So this will be the default name. It will come in. If you want to change, you can just select it, right click it, and rename it if you want.
Okay.
I just give some random name. Then after that, the first thing we need to do is define the workpiece. Okay.
Okay.
Just hold. I'll just come. One thing to note. Okay. Okay. So first thing what we'll do is I'll go into the geometry view. Double click on this MCS mill
Okay.
and bring it to the top here. So you know the height of this particular model, right? That is 50.
Yes, sir.
I had given it as 50, so I'll give the Z direction as 55. I'm not giving 50 itself. That is because I want an extra bit of material on the top.
Okay. Okay.
So I'll give 55 now. Click OK. Now you will see that it is a bit, there is a bit distance here, right?
Yes, sir.
Of 5 mm extra distance. So we'll compensate that. So what next what we'll do is we'll expand this MCS mill. Double click on the workpiece.
Okay.
And specify the part and blank. So click on specify part. Select the part. And we need to specify the blank. Select the blank, and the blank that I'm going to give is, since it is in the shape of a rectangle,
Yes.
I'll be selecting bounding block. Okay.
Okay.
So select bounding block. And also one thing to note is, since I have given the MCS mill of a distance of extra distance or clearance of 5 mm,
Yes, sir.
I'm going to give in the positive Z direction an extra stock of 5 mm. Okay.
Okay.
So give it here. That is in the positive Z direction.
Okay.
I can see.
In all direction X, Y, Z.
Yeah, I can see here in the limits. You need to give it in the positive Z direction. So it will come to the base of this coordinate system.
Okay.
So just give the value 5. Then click OK. Now the blank has been defined. Now, since we do not have any check geometry, no need to define that.
Okay.
Then I'll just change the material of the workpiece. I'll change that to, let's say, aluminium. Then click OK. Now the workpiece has been defined. Now the next thing we need to do is we need to define the tools or create the tools.
Okay.
So I'll be creating, let's say, 2 types of tools. So click on create tool. The type is, we'll leave it as mill planar.
Okay.
Select the tool subtype. So the tools we'll be using here will be the end mill type. Okay. Because why I'm using end mill is its uh, its end is a flat edge.
Yes.
Okay,
Yes.
flat end. So here we do not have any fillets. Fillets will be on the sides. Okay.
Okay.
So in that case, if we had any fillets on the ground or something like that on the sides here, we should have gone for a ball mill or something like that. Okay.
Okay.
But since we are not using or since we have pointed corners or edges, no need to go for that. We can select this mill, end mill. Okay.
Okay.
So select that, and the tool location will be in pocket one. So
Okay.
select pocket one. Now give the name. I'll give it as end mill underscore. It's a diameter of, since we are going for face milling, we need to mill the top face here. Okay.
Okay.
So for that instance, I am going for the diameter of 30. So D30. So click OK. Now you will see the tool. Now we require a larger tool here because we are going to face the top one. Okay.
Okay.
We are going for face milling of the top face. So that is why in order to remove a large amount of material, I am going to give a larger tool. Okay. So here I am only concerned with the diameter. No need to give any other or no need to change any other values.
Okay.
And you can see the material of the tool is HSS high speed steel. If you want, you can change the material also here. From here, you can go for carbide or carbide coated or HSS steel, anything like that. Okay.
Okay.
Now the only thing to note is the hardness value should be greater than the workpiece. That is why I am selected aluminium.
Okay.
So high speed steel has a much more hardness value than aluminium.
Okay.
That is why I am selected HSS as my tool and aluminium as my workpiece. Next, we need to provide the shank and holder. So select shank, define the shank. Then I'll provide the holder. Let me just adjust the shank length. 5. And the holder. Now, if you know the values here, you can give the values. Since I do not know the values, I will be retrieving a holder from the library. So select library, select retrieve holder from library. Select what type of class selection we are going for. We are going for a milling drilling holder. So select that, click OK, then click OK again, and you will get the library. So select any type, just check. So we check a smaller, if you select a smaller collet, you will see that it is not correctly fitting with it. If you select a larger collet, you will see
Okay.
this correctly fits with the shank. So you can select that. So we'll select that. I might as well give an offset of, let's say, 5. So it will be, the shank will be inside the holder, and click OK. So these are the required things we need to give. So click OK. Now the tool has been defined. Now we will go for the first operation. So come into create operation. Now we are going for the type called mill planar. Okay. In the other case, in yesterday's class, I went for the mill contour type. That is for another operation.
Okay.
So here, since we are dealing with planar surfaces,
Okay.
we'll be going with planar mill. Okay. So select mill planar as your type, and we will see the first operation, that is called floor and wall.
Okay.
There are different operations here: floor and wall with IPW, face milling with boundaries, face milling manual, like that. We'll go through all this, but we'll be discussing the important ones. Okay.
Okay.
So first I'll be selecting floor and wall. So floor and walls are the most easiest type of cutting operations, in which you need to show the floors that you are going to cut, the basement or the planar part that you are going to cut. Okay.
Okay.
So select that. Start with the first operation, floor and wall.
Okay.
Then select the program. Program has already been defined. Then the tool. We need to select the tool. Currently it's given as none. Select our tool. We need to select the geometry. Geometry is not MCS mill, it is the workpiece. So select workpiece
Okay.
and the method. So select the method as rough. So select mill rough. Now click OK. Now our part has already been defined. If you click on this display, it will show you that the part is already defined.
Okay.
Now the things we need to define here are the main thing is the cut area floor. Okay.
Okay.
This is the main thing to define. We do not have a check body since it is not clamped onto any bench vise or any type of clamping fixture. So no need to give that check body. We need to define the cut area floor. The wall geometry is not needed in our case, in this case,
Okay.
but in the later cases we require it. Okay. So in this particular circumstance, we will require the cut area floor. So cut area floor will be showing the area or the plane that up to which we need to cut.
Okay.
Okay. So specify the cut area floor. Click on this cut area floor. Click on the symbol to specify the cut area floor. Click on that and select the face. That is this face. Up to this face, we need to cut.
Okay.
So select that face. Click OK. Now that face has been selected. Okay.
Okay.
Let's see. So you click on this, it will show you the cut area floor. So this is the cut area floor. Okay. Clear up to this?
Something wrong here.
Hello.
Hello, sir.
Are you clear up to this?
Oh, sir. Here cut area not selecting.
Yeah, you need to select the cut area, this top face.
Top face I selected, then I press OK.
So what did it show?
All cut area must be belongs to the part geometry. It's showing. Once again, I will share my screen. Hello. Hello.
It is the workpiece. So we have selected.
Sir, cut area.
Could you zoom in to the operations there? First, you need to define the part. Specify the part first. The part has not been defined. I mean, did you define it with the other one?
Sorry, sir.
Okay, now it is defined, I think.
Part.
One thing, just close this operation tab. Yeah.
Okay.
Close it and then again open create operation.
Will planar.
Okay, floor and wall 1, 2, 3, 4. Let this work, please. Okay, and click OK. I mean, it's not showing that the workpiece is defined for some reason. Could you close this and let me check the geometry view? Could you select double click on the workpiece option there? Now the part and blank is not defined.
Initial time I defined it.
You need to define the blank also. Bounding block and give thickness of okay. Okay, then select. Yeah, that is all fine. Okay. Okay, now the part is defined. Okay. So when you see that it is defined, it will show that particular symbol. Okay, that torch symbol. So that it is already defined. Now select that face. Click OK. Okay. So I was telling you up to that, right?
Yes, sir.
Now I'll
It
share my
selected whole
screen.
face. This pocket also selected.
What?
Only top face selected or pocket also selected?
Only the top face is selected.
Okay.
Now if you want to see the top face, just click on that torch symbol. Can you see?
This one.
On the specify cut floor option,
Okay.
you just click on it and you will see. This is the floor area that it's going to cut. Okay.
Okay.
Clear?
Yes, sir. Okay.
Okay. Now what I'm going to do is, after defining that, come to the bottom settings here. You will see path settings. Okay. Now the method is already defined, that is mill rough. Now we need to see the cut region containment, cut pattern, step over, like that. Okay.
Okay.
So if you place your mouse over it, you will see the cut region containment. That is the floor. Okay.
Okay.
Here. So it is contained to the floors. Now you can also select it to the walls, and it will move towards the walls if there are any walls. But in our case, there are no walls outside here, only the floor. So just select the floor. I need to give walls. Then you can see the cut pattern. I'll come to cut pattern once we have generated it. Then there is one more thing called step over. Okay. So step over is something that we will see when I generate the cut pattern. Okay. So with these options, no, I'm not going to change any of the other options here, just going to generate it. Okay. So at the bottom part here, you see actions, and there you click on the generate button. Okay, this button. And if you click on that, you will see the cut pattern. So can you see?
Yes, sir.
This is the cut pattern you can see. So the cut pattern signifies different colors, right?
Yes, sir.
Here you can see the red color, the blue color, the yellow color, like that.
Yes.
Now, in order to understand what these colors signify, I'll tell you each one. So the thing that you see here, that is the cyan color lines, okay, or the light blue color lines are the the cutting movement. Okay.
Okay.
So the cutting movement of the tool is denoted by this cyan color. Okay.
Okay.
And the yellow color is denoting the engaging and disengaging. Okay.
Okay.
So it will be moving to the zero position, then moving towards the cutting bend. So it is not effectively the engaging or disengagement, but it will come to an initial position, then move into the cutting move. Okay.
Okay.
After that, it will be coming back to this position, that is at the end. You can see at the end. So at the end, it will be coming back here, and then again moving towards the axially, and moving to the next direction. Okay. So this blue color line is called the engagement. Okay. This blue dotted line is called the engagement line, and the red color line is called the disengagement line. Okay. So that is how we define this. Are you clear?
Okay, sir.
So the cyan color line is the cutting movement, and the yellow color is basically for positioning the tool.
Okay.
Blue color line is for engagement, and red color line is for disengagement. Okay. So you will see the pattern here. So if you see how it cuts is, the tool will be starting from here. So it will come down axially and cut it from here to here. Then it will move up axially. And you can see through the dotted line, it will be moving to the second line. Then again doing the same operation and repeating it again and again. Okay.
Okay.
Are you clear up to this?
Yes, sir.
So this is how the cutting pattern works. Now this type of cutting pattern is called the zig cutting pattern.
Okay.
Okay. Are you clear?
Yes, sir.
This is called the zig cutting pattern. Now we'll be discussing different types of cutting pattern, but when it comes to zig, this is the cutting pattern that it follows. Okay.
Okay.
Now there is another option called step over here. Now we'll see what is step over. So we can see here the step over is given as constant, scale-up. Then there are different options here. So just select step over and click on again generate, and you will see the generated toolpath. Now here the maximum distance for this step over is given as 50% of 2. Okay.
Okay.
So that 50% is meaning the basic area that will be engaged with the part. Okay. So when it is cutting the part, it will be engaging the 50% of the 2. That is what is meant by maximum distance. Now let's say I increase it to 75% and again generate this. We'll see that the number of cutting patterns will be reduced. Okay. So what step over essentially means is the distance between one cutting line or cutting move to the other cutting move. Okay. So the step over distance is meant by this distance, this horizontal distance. Can you see?
Yes, sir.
So this is the distance of step over. So if you are increasing the step over, let's say to 100, and again generating this, you will see that the number of cutting lines have been reduced, right?
Yes, sir.
Clear?
Yes, sir. Okay.
And if I increase it to 150 or let's say 250, it will reduce it again. Okay. So I can see only 3 cutting parameters. Now what we'll do is we'll just verify this to see how it cuts. So at the bottom here you can click on verify. In actions, next to generate, you will see verify. Click on verify. Then click on 3D dynamic. Then select if you want to see the tool displaying the dotted lines, you can select that. You can select either the tool display as wireframe like this. You can use it as a point, so it will show it as a point. You can use it as an axis, or the normal tool or the assembly. Okay. Now let's use it as a tool itself, and if you want to see the tool path, the cutting tool path, you can turn it on. Just click on all and it will turn it on. Okay. Then okay. Now we'll just see the value here. And just reduce the animation speed, then click on play. Now we'll see how it is cutting this. So can you see?
Yes, sir.
So the first cutting pattern has been completed. Now the tool will move along this direction, that is the red dotted line, and it will cut from here to here. Then again it will move up, then cut to the end.
Okay.
So this is the process. So can you say what is the problem here?
Step over is more, sir, to 50%.
Yeah, step over, since step over is very large, the number of cutting patterns is not compensating to remove the extra material that is being left behind. You can see here.
Yes, sir.
So this amount of material is being left behind, right?
Yes.
these parts. So and just reduce the transparency and everything. Okay, so basically you can see how it is being done. So this has been left over. So what can we do to compensate it? We need to reduce the distance, right?
Yes, sir.
So I'll reduce the maximum distance here from 250 to, let's say, 50 is enough. Okay,
Okay.
because when you are giving 50, it will automatically compensate the total phase. So again click on verify, then again do it. Now I am going to change the tool display to either point or wireframe, because if you are changing it to wireframe or point, the system processing will be much more smoother for the system. Okay, otherwise it will take some time for the system to select all this. That's why. So change the tool display to either wireframe and click play. Now you will see. So you can see how it is cutting it. So now it is properly cutting it, right? So this is what is meant by the step over value. Okay.
Okay.
So you can adjust it for yourself and see what is the difference. Okay.
Okay, sir.
Now currently the step over is given as constant. Now if you change it to, let's say, scallop. Now scallop is another thing. Scallop, what I'll do is I'll show you what is scallop. Are you familiar with scallop?
Scala, no, sir.
Okay, I'll just show you what is scallop. I'll just show you the image. So scallop is the natural smoothness of the profile. So can you see? So can you see certain indentations like this,
Okay.
like a wave,
Okay.
a waveform on this particular surface? Can you see?
Yes, sir.
Are you able to see this?
Yes, sir.
Just open up the image. So this is the image. So here you can see this is a flat surface, and when the tool is cutting it like this,
Okay.
you will see that the scallop is created like this, right?
Okay.
It's like a wave.
Okay, sir.
So the scallop measurement is based on the amount of surface that you cut. Okay, how finer you are finishing the material.
Okay.
Okay, so if you reduce the or increase the scallop height, it will bring certain indentations like this. So we are not required to get this. Okay, we want a fine surface,
Okay.
not a surface like this. Okay, so in order to avoid that, we need to reduce the scallop height. So here the scallop height is given as 0.01. So that is very less. Now if you want to, let's say, increase it to 5, and we'll generate this and see what the difference is. If we'll see any scallops. Now in this case you won't see any scallop. That is because we are using an end mill. Okay. Now if I increase the scallop height to, let's say, 25, and I'll just change the tool. You can change the tool whenever you want. Okay.
Okay, sir.
So here we are using an end mill, right?
Yeah,
So if
yes.
you want to change the tool, you have an option called the tool tab here after geometry. So if you expand the tool tab, you will see the tool given here. Now, if you want to edit the same tool, you can click on edit.
Okay.
And come into here and change the tool parameters. You can change the tool parameters if you want. So this is basically an ML. So it won't give you any different types of scallops. So in order to give a scallop, you need to increase the lower radius. Say I'll increase the lower radius to 20, 10. Okay, now you can see. So it will have a curvature like this of 50. So we'll change it to this. Okay.
Okay.
And the scallop height have given us 25. I'll again increase it to let's say 50, and we'll see there will be any difference. And press on play. And we'll see the difference. So can you see the difference here?
Yes, sir.
So this is the surface that you will get.
Okay.
And these kinds of structures are called scallops, like a waveform, right?
Okay.
So this is something that you will get when you are using a ball mill, like this. But when you are using a end mill, you won't get it like that. That is why we prefer end mills in planar surfaces, when milling planar surfaces.
Okay.
Okay.
Okay, sir.
So I am going to again change the tool. So come into the tool tab again. The tool is already defined here. Just click on this for edit and display. And I'll again reduce the lower radius to 0. Okay, so that is known as scallop. Then percentage of tool flatness is the same thing as that of the constant size. Then the passes. Passes also is something that you will see. So passes is something that you can definitely define here. Now, if you want to give, currently the passes is given as 1. Now, if you just generate this or verify this, you will see that the cutting will be like this because it only has a single pass. And if you increase the pass to let's say 4 and generate it, you will get the 4 passes. So I can define it this way also. Okay. Now, if you want to increase it to let's say 10, or I would say the ideal one will be 8. 8 is the ideal one so that it cuts all the material.
Okay.
Okay.
Okay, sir.
So these are the different ways in which you can define it. So we can give passes. Then variable extract is also something that we can give, but you need to know the maximum and minimum distance in order to give that. And exact is also the same thing as that of the constant and percentage of tool flatness.
Okay.
You can give any of the parameters if you know this. Okay.
Okay.
Otherwise, go for constant or passes or tool flatness. Now, we'll come to the cut pattern. Now, the cut pattern we were using here was the SIG pattern. So, SIG is like the same thing. From the name itself, you know. So, it is starting from one place, coming to the other, then moving on to the same position, then again cutting, moving to the same position, again cutting. So, that is called SIG.
Okay.
Now there is one more type of cutting pattern called zigzag.
Okay.
Okay. So what zigzag does is basically goes around and around. Okay. That is what zigzag does.
Okay.
You're familiar with the zigzag shape, right?
Yeah.
Like an Z. So that is the way in which it cuts.
Okay.
So we select zigzag and click on generate. You will get a pattern like this. You see,
Okay.
this is the zigzag pattern. I'll just generate the cutting pattern. We'll see. So what this effectively does is that it reduces the tool to engage and disengage.
Okay.
Okay. So it can cut in a single pass.
Okay.
Clear?
Okay, sir.
So when you're trying to cut a material or creating a workpiece, you need to cut it efficiently, right?
Yes, sir.
So when you're using the SIG pattern, it is not entirely efficient because the tool is always engaging and disengaging, right?
Yes, sir.
So by doing that, the machining time will be increased.
Okay.
But when you are using a zigzag or any other type of cutting pattern, it will cut it in a single pass.
Okay.
The only thing provided is that the depth should be considered here.
Okay.
Okay. When you are cutting it to a higher depth, there might be some chances that the tool might break off.
Okay.
Because of that stress, because of that shearing stress. Okay.
Okay.
So in order to avoid that, you need to view the depth of cut. Okay, in which depth I can cut. So that kind of thing, if you are cleared with that kind of parameters, then you can cut it using the zigzag pattern. Okay. Now, how I know that it is cutting in a single pass is that if you look closely here, it is having a single cut pattern, right?
Yes, sir.
And it is not having any levels. Levels meaning, in the other case also it doesn't have any levels. It was just cutting as it goes, right?
Right, sir.
But since that is because we are not provided any depth of cut. Okay.
Okay.
Now, if you are providing a depth of cut, it will cut it accordingly. Okay.
Okay.
So that will come to that. But zigzag, you understand the cut pattern zigzag, right?
Yes, sir.
Okay. Now I'll change it to, let's say, sig with contour, and we'll generate this again. So sig with contour is a different thing. That is, you can see from the, it's sort of similar to sig, but the only thing it is taking into consideration is that the contour is confined. Okay. When you are considering the sig only and generated it, the cutting pattern was going outside the workpiece, right? You can see that the cutting pattern is still going outside the workpiece.
Okay.
So when you are cutting with the sig with contour, it is confined to the rectangle or the workpiece here.
Okay.
Okay, that is the advantage to this. Now if you verify this type of cutting, we'll see. So you can see how it is cutting it. Now this has a lot of engagement and disengagement, right?
Yes, sir.
It is going up and down like that. Similar as in the way of sig. Here.
Okay, sir.
So this is not also an efficient method to do. Now next what we'll go into the other operation, cutting that. That is the first operation here, which is called follow part or follow part. So select follow part, click on generate, and this is the follow part method. So the tool will be engaging from the middle portion and it will be cutting towards the outside.
Okay.
That is the follow part method. Okay, so the tool will be engaging from here, moving towards this direction and starting it from the center. So it will cut it in this direction. Can you see? From here, like that. Okay.
Okay.
Now we'll see the cut pattern. On verify, on play. You can see. So it will start cutting around the sides and will come to the center and again disengage. So this is also one efficient way to cut, since it is cutting with a single pass.
Okay.
So you can see. So this is follow part method. Okay.
Okay.
Clear?
Okay, sir.
Clear with this follow part.
Yes, sir.
Now another cut pattern is follow periphery. If we select that, the only difference in that is we say it is kind of same as that of the follow part method. You will not find a difference here, but the only thing is that it will be starting from the center instead of starting from the end. Okay, so it will start from the center and go towards the boundaries. That is how it cuts. So it is relatively opposite to the follow part option.
Follow part also same like this.
Follow part.
Follow part also a tool path is same, right?
Yeah, tool path is same, but only thing is that from the follow part, it will be starting from the boundary and going towards the center.
Okay.
It will be cutting from the boundary to the center,
Okay.
but in the case of follow periphery, it will be cutting from the center to the boundaries.
Okay.
That is the only difference. The movement of the tool will be different, entirely opposite.
Okay.
That is the only change. And there is one more, another type cutting pattern that is called the profile.
Profile.
Now, if you select profile and generate this, is again, in this particular case, I cannot do the profile one. I'll show you in another one. Okay.
Okay, sir.
Because profile and recordal are different, a special type of cutting. Now, if you go for trochoidal, a difference I'll show you. So if we select the trochoidal pattern is basically used for cutting cavities.
Okay.
Okay. Cavities meaning inside the a particular workpiece. If you want to cut, so the main example is the slot. If you want to cut the slot, you can use this particular type of cutting pattern. Now, how it cuts is, I'll show you. So it will cut from the ends, like in the case of periphery, but its movements will be quite different. But in this case, you won't find the difference between trochoidal and cutting periphery because there is a special case involved. I'll show you the trochoidal pattern. Pattern is not quite shown here. In this case, you won't notice a difference. So in another case, I'll show you. Okay, the trochoidal pattern.
Okay.
So these are the cutting patterns available to the figure. So you can use any of the type, but the efficient methods are the follow part, follow periphery, trochoidal, and zigzag. Okay, you can use any of those. Okay, so I'll go for zigzag for now. And you need to define this one, that is the floor blank thickness. So here there are three options: floor blank thickness, depth per cut, and is the depth offset.
Okay.
So the floor blank thickness is the thickness that I have provided on this particular job piece. So what? How much is the thickness that I provided? 5, right?
Yes.
I had already given a thickness of 5 mm.
Okay.
Do you remember?
Yes, sir. 5 mm.
So that is the distance that you should write here, or the depth that you should write here for the floor blank. That is because we want to reduce it to a distance of 5, right?
Yes, sir.
We need to get the original face here.
Okay.
So that is why I am giving the floor blank thickness as 5. Okay.
Okay.
Then you need to provide the depth of cut or depth per cut. So when we are generating this, you will only see a single level for cutting the whole workpiece.
Yes.
Now, if you are giving the depth of cut, let's say 1, and again click on generate. Now you will see almost 1, 2, 3, 4, 5 levels. Can you see?
Yes, sir. For 5
So it will be cutting each mm or a single mm, 1 mm will be cut through each pass
Okay.
or each level. Okay.
Okay.
So understand what is depth per cut. Now I'll just verify this and show it to you. So it will be cutting the whole material 5 times.
Okay.
Clear?
Yes, sir.
I just play this so you can see. So it will remove the 1 mm layer first. Once it has removed the top layer, then again it will start from the end and remove the second layer. So it will do like this for 5 times.
Okay.
It will repeat it for 5 times. So this is how you can maintain the life of the tool and also reduce the wear of the tool. Okay, now if you are cutting it in a single blow,
Okay.
there is chances for the tool to break off or rupture. Okay, that is why we are giving the depth of cut. Clear?
Yes, sir.
And the set depth offset, currently we do not require this one, so no need to give it for now. Okay.
Okay.
So these are the operations involved in this. Now, one more thing we can see in the other options we can see here is the cutting parameters, non-cutting moves, and feed and speed. So I'll tell you about what is feed and speed. So if you select feed and speed, you are basically defining the feed of the basic tool. Okay, so we can define the surface speed, feed per tooth, and spindle speed. So I'm going to give the spindle speed of up to 300 or 3000 RPM.
Okay.
Once you give the speed, it will automatically calculate the surface speed and feed per tooth. So either you give the, if you know the surface speed, feed per tooth, or spindle speed, you can give either of these.
Okay.
And when you click on the symbol, it will automatically calculate the other values based on the given value. Okay.
Okay.
Clear?
Okay, sir.
So that is how you can give it. So that is feed and speed. Then next thing is the cutting parameters.
Sir, feed
Now,
per tooth, that one.
what?
Feed and speed. We entered
Yeah,
RPM, spindle speed only.
yeah. I had entered the spindle speed.
Uh,
Once you enter the spindle speed, you can click on the symbol to calculate the surface speed and feed per tooth. It will automatically get the software will automatically calculate it.
okay.
No need to give it.
Okay, sir.
Okay.
Okay.
So after that, you will see the cutting parameters. So the cutting parameters, if you click on this, it will show you different options. There are different options here, that is strategy, stock, corners, connections, containment, more. These are the different options that you will see. But in our case, I will not be covering all because we need. I'll be coming into other operations, and we'll utilize all these options. Okay. Okay.
Okay. So where is cutting parameter?
Cutting parameters is right about here. We can see next across to cutting
Okay.
parameters. You will see this symbol.
Okay.
So just click on that, and it will open up the cutting parameters.
Okay.
So what cutting parameters does is the options related to the cutting of the workpiece.
Okay.
So there are different options that you can change in order to cut the object in a particular angle or something like that. Okay.
Okay.
Now you can see when you select cutting parameters, you will see an option called strategy. And your tab called strategy, and here you can define the cut direction. So there are two types of cut direction. Here there is the climb cut.
Okay.
That is the tool going against the workpiece, and the tool will be rotating in the anti-clockwise direction. Okay, that is called climb cut.
Okay.
Then there is the conventional cut. So conventional cut will be the tool going against the workpiece and cutting it in the other direction. Okay. Clear?
Okay,
So
sir.
you can cut it in either way if you want.
Okay.
Then there is the cut angle. Cut angle is given currently automatic. Now if you want to specify a cut angle, you can specify the cut angle. Let's say the angle is from the x coordinate. Okay, that is this coordinate. Now if you want to, let's say, change the angle to 45 degree, it will change it according to that. Okay, cut angle will change like this.
Okay. Tool will come.
So it is the cut angle from the x direction. So this is the x direction. It will be tilting towards this. Now we'll just see. If you generate it, you can see the cut direction. Can you see how the direction changed?
Okay. Okay.
Okay.
Okay.
If you click on verify, you will see how it cuts. So it will cut the workpiece in this way. Clear?
Yes, sir.
So that is what the cutting parameters does. So this is just an option inside cutting parameters.
Okay.
So we can give it in this form. Now I am going for automatic itself, so it will automatically recognize that. And there are different other options here. You can give the stock. Stock is for giving the extra material left behind. Okay. That is the stock, part stock. That you can give. We'll be coming on to all that in the other classes.
Okay.
So that is about cutting parameters. Then there is the non-cutting moves. That is the non-cutting parameters. And you can select that option by clicking it here. So it's just down to the cutting parameters.
Okay.
Just below the cutting parameters, just click on that simple. Now this deals with the engagement and disengagement of the tool. Okay, how the tool should engage and how the tool should disengage.
Okay.
So it will be giving the disengage type, the ramp angle and everything. So how the tool should approach it, either helical form, you can give the diameter for the helical form, the total dia, then the ramp angle, how it should approach the workpiece, then the height of the the workpiece, not the workpiece, the tool cutting direction. All these things can be defined here. And also same as in the case of retracting. Then when you are cutting smooth corners, drilling. So these are the different options, but we'll come to all this, but no, it is not required by us in this case. Okay.
Okay.
So we have generated this. Now you will see this is just the programming for the current operation. Okay.
Okay.
I can see the programming here. So this is the system language. Click OK. Now our first operation has been defined. Okay, floor and mode. Clear?
Okay, sir.
Now we need to move on to the second operation, that is cutting the slot inside. Okay.
Okay.
So for that we need to create another tool. So first thing what I'll do is I'll be using the same tool for cutting the slot inside here. And after that we will be using a smaller tool, an end mill of a smaller size. So I'll select the create tool option. The tool location will be pocket 2 and I'll name this as end mill underscore 12. I'll give a diameter of 12. This will be the finishing tool. Okay.
Okay.
So give its diameter as 12. You can define the shank. I'll give the shank length as diameter as 25. Length we will reduce it to 45 and provide a holder for it from the library. You can retrieve the holder from the library. Select milling drilling, Click OK and select a smaller folder. This is quite large. Select a smaller one, either this or this one. Okay, this is fine. Now the only thing to make sure is that the float length is hardly given, that is 50. Okay, that is enough. So just click OK. Now that has been defined. Now click on create operation. Now you can do the cutting with the same option. Okay, floor and wall. So select floor and wall again. Now we will be using the same tool, but we will be doing the roughening process. Okay.
Okay.
So click on OK. Now instead of showing the top face, now here we need to show the cut area floor as the inside part. This is the face that we should select next. Okay. For the second